small presentations by researchers or industrials working in QKD, especially QKD network, with a panel discussion. So, so the three panelists are Don Hayford, who is here. So Don is a research leader in the National Security Division at Battelle in the USA, and he's working on the large QKD network program that he will present. We have also Dr. Yong Zhao, who is here, who is the CEO of QuantumCTek. So it's a company one of the companies that is presenting his products in the industry exhibit. And so it's a company from China, and he will also present their work, product development related to QKD network in China. And we have Professor Masahide Sasaki, who is here. Yeah. So you can all come down. Actually, we will sit here. So please come down so we get equipped. So Professor Masahide Sasaki is director of the Quantum ICT laboratory at NICT in Japan, and he's also leading a large research program on quantum information and QKD network that he will also present. So we'll start with Don.
All right, so let's get going. I know everybody wants to go to dinner, so. Ramon said we had to be done in 10 minutes, so these gentlemen here will answer my questions for me if we don't get there. All right, so I'm going to talk to you a little bit about who Battelle is and why we're doing this. And then we'll talk about our overall goal, the project itself. There's some network information that I'd like to share with you, and then you may have also seen a poster lead Osterling did on some of our lithium niobate nonlinear devices that we're working with different universities on, so I'll just show you that. So who is Battelle? So Battelle is a large R&D organization. We're located in Columbus, Ohio, which is in the middle of almost nowhere, but not nearly as nowhere as Waterloo, Ontario. So we manage 8 national labs, 7 in the US, 1 in the UK, but mostly what we do is contract research. And contract research, of course, people come pay us money. We work on their problems. The profits, even though we're a nonprofit organization, some of the profits go to charity, the rest of the profits go into projects like this. So it's a nice thing. Just to give you some idea of some of the things we work on. For example, Battelle invented Xerox. Most of you probably don't know that. The desert bar, I always mention that one. It's a chocolate bar that won't melt in the desert. Since ID Quantique is in Switzerland is one of our partners, they don't like the fact that we make chocolate that doesn't melt. I have to tell you, it doesn't taste nearly as good as the chocolate that you get in Geneva. One of my favorites is this air-powered grappling gun. You see it right here, the guy shooting it off. Designed for SOCOM, so that they can board ships out at sea. Supposedly you'll see it in the next James Bond movie, so if you see it, this is where you saw it first. And kind of a cool one that people are working on right now is this NOAA bridge. This is Ian Burkhart. He's a 23-year-old Dublin, Ohio native who suffered a neck injury during a swimming accident and complete quadriplegic. So Ohio State University has implanted this device on top of his head, which reads some of the neurons inside. Battelle built this device that you see here that does 3 things, or 2 things. It reads the neurons up here, and it learned by giving Ian a simulator how to move his hand. And then they also have these electrodes that attach to his arm. And so for the first time, a few months ago, in 4 years, Ian was able to move his arm, pick up a spoon. So he can't feed himself, can't walk. That's a ways away yet, but it's years now instead of decades. So I think it's a pretty good thing. Our partner, of course, is ID Quantique. I won't say anything more about them because everybody knows ID Quantique. So about 3 years ago, actually at the conference in Zurich, I approached Gregoire and I said, so Gregoire, this QKD stuff's pretty cool, but it has some issues. First of all, you can't really do data sharing over large networks unless you do a lot of routing and encrypt, decrypt, and that kind of thing, which doesn't seem all that secure. You can't connect remote locations at all. There may be connections that are close enough for QKD, but there's no fiber routing, so you have to install expensive fiber. And if you want to try to do something like wire up a bank with all its branches, at some point, this point-to-point network becomes really impractical when you start to think about how many systems you'd have to put inside a bank. So we approached ID QuantumCTek and said, so what do you think? a trusted node would be kind of a cool thing. And Gregoire said, nah, we're not interested. But fortunately, a few years later, or a year later, so he came around and we started working on this project to build a trusted node. So here you see a picture of the trusted node. It's in a telecom-compatible architecture called ATCA. It's Advanced Telecom Computer Architecture. It's a two-blade system, so you can see here 2 blades, so we'll plug in there. Now we teach our guys when they're trying to order stuff, if you see a drawing on the website, it's probably not real, but if you see a picture, it probably is real. So does anybody want to guess, is that real or not real? So Photoshop is a wonderful thing these days, right? So this is actually a 3D model. But we're in the process of taking this model now and integrating the parts so that in about 6 months you'll see this as a real thing. The trusted node, of course, the standard architecture is to hop keys across a network that's connected by quantum keys. In order to get certification, FIPS 140-2 certification, for example, we combine standard classical public key infrastructure kind of things that are approved by FIPS along with the quantum stuff so that even though they don't trust us and we don't trust them, together we have something that's trusted by everybody. And of course we're using the latest version of the CAL system. So we started operating the first commercial QKD system, and by that I mean the first non-government funded QKD system about a year ago. We operated in our labs for almost 2 years before that. We have trusted nodes that will be installed in 3 locations around this ring in Columbus, Ohio. This ring is about 100 kilometers in diameter. Right now we have an existing system that connects our manufacturing facility with our main location. And ultimately we plan to connect our Ohio location to our offices in DC. One of the things I'd like to announce is that the City of Dublin has given us access to some extra fibers. So now we have 202 sets of fibers in this ring and lots of fibers in this ring. So we have a 100-kilometer diameter and 25-kilometer diameter, circumference. Fibers that are available to QKD researchers, other quantum researchers. If they want to bring their equipment to Columbus, nice place to visit, not Paris, we'd be happy to have you. We haven't, because we just received permission to use this, we haven't actually figured out how we're going to do this. It will be on a non-profit basis, but there might be some costs associated with using it. But if you're interested, let me know. We'll figure out how to do it. Ultimately, our goal is to put a quantum network across North America. This is a goal that we share with ID QuantumCTek and some of our other partners like University of Calgary. And that's where we're trying to get to. The pipeline device, so one of our other areas is sort of the low level, trying to bring up or help people work with quantum repeaters and quantum memories. And so Lee, for example, has done a lot of work building a single device that puts together the nonlinear device, a heater, that kind of thing. It's optically, or it's connected by optical fibers so that, so that you can, that's all right, that's okay. Which gives you a more consistent, it does have a slightly higher loss than if you're just doing air coupled. But it also has a built-in heater, so you have good control and that kind of stuff.
So maybe I missed it, but who will be the users of this network, and how much will they pay to use it? Or?
There are several business models that we're looking at. We think industry, banking, medical records, those types of industries will be the main users. We're aimed more at commercial markets rather than government. So that's our target area.
Presently, it's funded. It's like a government type of funding, but you expect to sell the service. This is.
I'm sorry, I didn't hear that last part.
Presently, the investment is funded by government funding, as I understand it, but then you expect to make a business from the users.
Yeah, so this is funded both by ourselves at QuantumCTek, and we do expect to make a business out of it.
If you want to cover from the west to the east coast, how many links do you expect that you would need?
So I can't understand the sound is not very good. So
if you want to cover through the whole United States with this kind of network, how many links would you estimate you will need?
So it takes probably, with the equipment as it exists right now, probably about 75 links to cover the going across the U.S. in one direction.
So your nodes where the links, one link connects to the next, don't have quantum repeaters yet, so that you have to have some sort of trusted node. How do you make it trustworthy?
Well, so first of all, we follow all the guidelines from the federal government and others for how do you build cryptographic equipment. And so part of it is it's contained within a secure boundary. You have tamper detection and that kind of thing. And then you have to be careful how you build it, how you design it, and all of that. So all of that goes into the final product. And what we have is the blade system. So you put multiple blades in one rack, and then they have a way to communicate from blade to blade so that you can share the key across the blade. And then, of course, from there it goes out to the next one. But it's built using good engineering practice.
Good afternoon, dear friends and colleagues. So thanks for the organization of the conference. So I have an opportunity to share our experience and our progress and even concern about the quantum industry in China. So let's go directly into our discussion and the topic. So and you guys can call me Yong, the pronunciation Yong. Okay, so few sentences about our company. So the company named QuantumCTek actually is the short name for the longer one. We call it Quantum Communication Technology Corporation Anhui. Actually, it is initially founded by the University of Science and Technology of China, and also other private investors. So actually, the university make a package, put all the related knowledge properties before the year 2009, and they make a package transfer into the company. And we start from that point. We continue developing and researching and managing and engineering the product and then doing the market. So now the company has grown to be now is the biggest one in China, focused on quantum technologies actually. So we have 4 branches. One headquarters located in Hefei, and here also the university is located as well here. So we have another 3 branches. One is in Jinan. This one is the research institute, belongs to our company. Another 2 branches located in Beijing and Shanghai, where they focus on marketing and application research, solution development for the customers. So what we have now, the company has grown faster, very fast. We have now about 200 members working together. So we have done a lot of test bands on construction and commercial applications, something like that. So if we connect all the fibers, and the commercial fibers actually we work on, connect them together. So the total length actually, I think is about 1,500 kilometers. That means we already equip our products along this distance, but there's a small network. Okay, so that is pretty about our companies. And okay, for the YQKD and the YQ network, I think most of the audience here, you are the expert, and I want to skip it because we want to save some time, so have discussion. And here about some cryptography at present, a symmetric one and symmetric one. So if we can fill this part, so I think the conventional cryptography expert, they will be happy. So we can make this symmetric cryptography much stronger if we can do more, and we have the very efficient key exchange protocol, so we can do one-time pad. The unconditional security maybe can be realized. So, okay, among the new promising technologies for QKD, for example, the quantum noise encryption and the post-quantum cryptography, maybe something more. And I think we from the view of the cost, the proved unconditional security and anti-quantum attackability, so seems like the QKD seems to be the most outstanding one. So for the future key infrastructure. So we set our goals to secure communication networks over quantum key distributions. So we describe our system with 5 layers, the 2 blocks. The bottom layer blocks is for key infrastructures, the top one for applications. And we have 3 layers. The very bottom layer, we have the quantum modules, convergent nodes, trusted relay, optic switch, and we also work for towards the quantum repeater in near future. And also, under the second layer, they determine the topology of the network, local area network, and the metro area network, and even the wide area network. So the third layer, from the top to the bottom, bottom to top, the third layer is a full control of the network. It can control the generation, the distribution, the storage, usage, the discard of the keys. So this plenty of things here is formed out of QKD networks, and then we give the keys to support up blocks to, for example, the encryption platform. So we provide service to the customers, for example, the phones and data transmission in the near future with the e-bank, smart grid, something like that. So it is pretty much what our company is doing, and what else systems can be described like this. It depends, no matter how complicated the networks looks like, so they all work in this way. So here we jump to another part. We can draw a roadmap of the QKD network in China from the year 2006 until now. So I will not cover all the results, but only remark some I think the remarkable results in China. So the first, I want to mention in the year 2006, there were 3 groups in the world. So they pushed a secure distance limit up to 100 kilometers using decoy state. So one of the groups is from China. It's a Jianwei Pan's group. Okay, so in the year 2008, Jianwei Pan's group finished the quantum phone network. Actually, they used the phone application, apply the quantum key distribution to the phone application, use one-time pad. And in the year 2009, the group pushed the secure distance up to over 200 kilometers. In the meanwhile, the all-pass metro area network with 5 nodes finished in Hefei as well. So this is from this point. So QuantumCTek, our company, and joined the game. So by the year 2012, so we built a Hefei metro area network. So with 40 nodes for the users and 6 nodes for the network points. So actually, this test bed is still working only for our company. Our company owns this, and all the products we deliver before they delivered, we have tested in this in-field test. So later, we sell this big network. Actually, it's a bigger one in another city in Jinan. So we build for 50 terminal nodes, and so 6 for the gate for the network. And then this one we sell it to the local government. They use it as a test bed, not for the techniques. It's for the application. So here is the bigger picture. So we have 3. We call this a central control station. They form the loop topology, and they are in charge with the small area. And the central control station work like a convergence node, and also work like a trust relay. So the central control station can be arbitrarily connect to each other to form arbitrary topology, and they can extend this distance. So what is the service we provide? Actually, all the service, they're on the desk. So in front of you, there is a phone, the audio one, video conference system, and you have the fax machine and also the computer, some application inside you can send the data. So all the data collect together and through the Ethernet, for example, connect to the terminals. The terminal works like a gateway, so encrypt all the data and send it out to another terminals and then decrypt it. So like this. So each terminal node can provide more than one service. So we have now here 90 users actually, but the ability of this network can provide several hundreds of users. So they can choose they can choose the one-time pad or the combination between the QKD and the conventional cryptography. So we suggest them to use the second one. In other words, we have limited data. The limited quantum key. So this network is still working 4 days, 2 times 224 hours, already for 9 months. It's very stable. For our company, it's also the big sale. For us, it's nice. So the year 2014, right now, so we all know, so from the previous talks, we know there's a very interesting, promising, and it's nice big project from Beijing to Shanghai, over 2,000 kilometers. So actually, this big project is organized by a group. The group contains the government, the university, the telecom carriers, the potential customers. Actually, a lot of banks get involved. So our company now is working hard, so we can trying our best to manufacture, to design the product and also the solutions meet the requirement of this big project. So actually, we are one of the potential candidate actually. So I think we are very promising because we are competing with other companies within the country, but we are the biggest one, so we are very confident with that, but no guarantee as well. So from this roadmap, you can see in China we are trying our best step by step, try to speed up the realization of the wide area network for the QKD settle in China. Surely later we will. Not we, so the Chinese Academy of Science, they will launch a satellite. So this 3D huge QKD network will be realized, I think, within 3 years in China. So it's pretty much the network progressing in China right now. So let's jump to our products. So make it very quick. So we have already make a lot of products can be set into the different categories. For example, local area network, the metro area network, and the wide area and the applications. So for the local area network, it's so black. This box is the optical switch. It's all-pass optical switch. All the terminals can equally, connect to this one, and this one create interactions between any two ports to provide a very standard single mode fiber path. So all the terminals, they communicate to each other without any phone transfer to electron, though there's no that way. So it's very high secure. The communication, the standard fiber path. So inside. So but they also provide some loss. So this setup can make the service, but the range is limited because of some loss. It depends on the terminal's ability. So also can be a control inch. Okay, for the terminals, it can work both for local area network and the metro area network. The terminal. So the protocol we are using is BB84 decoder state protocols, and with the polarization encoding. So as we mentioned in the previous slide, we use the all-pass type, all-pass optical switch. All the terminals has to work equally. That means you have to work as a transmitter and the receiver at the same time. So we make the special design. We call it transceiver. So that is our transceiver looks like. This front is the rear, and all hardware design compact for you chassis, and designed to resist all known quantum hacker, for example, the blinding of the detector, something like that. And the optical path loss tolerance up to 18 dB. So it's a compact one. And also for the metro area network, we have very, very, very important product that we call the central control station, as I mentioned before. So we have our key generation controller, a key relay router receiver, and a server, and the network management all in the controller, in this station. And also we use the time division multiplexing to reduce the total loss. That means we have less, the terminals inside the central control station, but provide the connection and more than the inside one. So the outside can be 16, inside can be 8, something like that. They are not always connect to each other. So it's on demand. Okay, so this slide is about trusted relays. I think we have lots of reasons why we use a trusted relay, but this part is I try to from another view. So might be the case. I will jump it. Maybe we can discuss in the lecture later. So we have pronounced another unit. It is designed for the backbone network. It's gigahertz QKD modules. It's all hardware designed compact, and the photo path loss tolerance can be up to 24 dB, and the ATC adapt as well. So that's pretty much what we have in the QKD, and we have applications. We combine the QKD and with the conventional encryptor. So this one can be a 10 gigahertz bit per second, and the key refreshing key, and the rate can be 1,000 keys per second. And also, it complies with Chinese national standards with the certificate. It can use in a commercial application right now. So I also use the quantum key distribution combined with the VPN to as a dual key structure, something like this. It's worked well. And also, okay, so some commercial service case, so for the government, something like that. We just make a parallel network for generating the keys and then provide them. So, okay, so like the loop one, and this one is for one company to get involved into the big project. So something like this. So okay, thanks a lot. We have lots of collaborations with a lot of institutions. And thanks for your attention. We have more than QKD products. So like this. Thank you very much.
Do you sell the QKD modules outside China?
What?
Do you sell the QKD modules outside China? You have very impressive deployment nationally, so it seems you targeted first.
We focus within China because the ability we produce the products. So we don't. So if we have more than 50 people, maybe we can produce more, because now we have to meet the requirements within China. So the requirement is huge number. So we are thinking about to sell it outside.
You sell it?
I will. We will. So right now we don't.
Let me briefly explain Japanese industry efforts on QKD application. So let me start with the two facts and discuss their implications. Fact one, high-end users like Ministry of Defense are seriously worried about security threat on the physical layer after the Snowden file, but they have not decided yet to introduce QKD. They are just watching. In general, strongest security is not necessarily a reason for the scheme to be adopted. So there are many strong crypto schemes, but most of them have not been used in practice yet. For example, most users still use RSA 10.24 even after doubling the key length was strongly recommended. So as you know, the current RSA scheme won't work anymore against the latest computers. And this requires a tedious replacement of the various systems, and most of the users still stick in the current RSA scheme. So maybe the implication of this fact is that standalone QKD is hard to be accepted. Okay, so let's start with an existing security system, then integrate QKD into it and realize new values. Okay, new values may include the following. So updating the scheme itself is not necessary. So this is sharp contrast to the algorithmic crypto, which is not provably secure and hence need to be updated. And QKD can detect hacking, and more importantly, QKD is based on the simplest encryption. It's XOR. So there is no latency at all, and seamless cryptic connectivity can be realized if key IDs are properly managed. And this is a really good news for high-end users, because the specification of high-end solutions are usually not disclosed. And this makes very hard to interconnect the systems of different divisions, even in the same organization. Okay, fact 2. Responses to our press release on QKD technology remarkably increased this year. So we have released the QKD-assisted secure smartphone this May. And the potential customers who have asked us on it includes ministries, prefectural office, general construction company working on the hospital, banks, car companies, and print company. So they are looking at the future society based on the Internet of Things and want to know what kind of security technology they should introduce and how to revise their security systems. So the conversation with them are really inspiring. And I'm sure that the QKD key plus smartphone is something marvelous. So let me briefly mention what is a QKD-assisted secure smartphone, and we apply it to hierarchical access control of the data files. So there are a data center and a service terminal, and we share several kinds of keys via QKD, and we consider here 3 kinds of keys, okay, and assume 3 users, and access control rights are properly managed. And first, these users should receive keys to the smartphone, and we apply Beg-One-Kata protocol for authentication. And at data center side, several data files are encrypted by these access control keys. And then we further prepare data encryption key, and data are further encrypted by this key and then transferred to the service terminal. Then user try to get access, and first user can make a full access to the data, but the second user have a partial access, and the third user cannot access to the confidential data. So it's a really simple scheme, but it's really useful to protect state secrets and medical chart. So the implication from this fact is that there are new fields where the security is becoming a new concern. So the modern crypto and the QKD are in the same start line. So these new fields include a medical network and controller area network and robot network and so on. And the main issue is how to share the symmetric key between control units and how to manage them. So the security standards have not been decided yet, so it's a big chance. Okay, so now NEC is integrating QKD into a commercial product, QuantumCypher. And most of mission critical channels are made in the second layer, the data layer, not going up to the third layer, IP network layer. And QuantumCypher is set just in front of the layer 2 switch and encrypt the data stream directly at the throughput of 10 gigabps. So this is a standard speed of optical communication. And we introduce a QKD and to the QuantumCypher, then we can enhance the security of AES by the key refresh. And the one-time path mode is optional for high-end use. Okay, so this is a NEC demonstration model. So this is a half-inch log size, and the typical key generation rate is 100 kilobps over 60 kilometers. Clock rate is 1.24 gigahertz. Toshiba is also developed a really high-speed QKD systems and slightly faster than the NEC ones. And this system is put to the field trial and marked largest ever volume of secure key in the field. And they use a fibers over poles, so it's a really severe condition. And their target is to realize a secure, smart community. Mitsubishi also develop a QKD smartphone and also apply privacy amplification technology developed in QKD field to modern cryptography. So typical example is a physically unclonable function, and we use a really unique fingerprints of the device characteristics, such as the distribution of the delay time of the transistor, and we use a privacy amplification to extract the key. So this is implemented in the IC chip. Okay, so now Japanese consortium is making a QKD showcase for Tokyo Olympic in 2020, and the concept is the safest Tokyo network. And a new program called Impact will start from this October for 5 years. This is funded by the Cabinet Office. And this biography is our mission statement. So the basic concept behind this is security defense in depth, and we are making the multi-layered monitoring and protection system. So I think this is an important direction for the collaboration with the modern cryptographer and cyber security engineers. Okay, now finally let me mention a new frontier. It's a satellite airborne network business. NICT have constructed 4 ground terminals to track the satellite by laser link. And now the small satellite, Socrates, was launched this May and was successfully put on the low Earth orbit now, and just under the preparation test. And maybe satellite ground laser link will start soon at 3 different wavelengths. And we also evaluate polarization encoding at the photon level, and also evaluate the footprint jitter and also a wiretap risk. But I have to point out that the QKD is really hard to implement at this low Earth orbit altitude. So this view graph shows how decoyed BB84 falls off to generate a reasonable secure key rate. Okay, this is a low Earth orbit altitude. And this solid line is a ppm capacity without no security. And you can see a really huge gap between this. And maybe we would like to put some security to this curve. So maybe algorithmic crypto is a first option, but it's really hard to update in satellite when the scheme is weakened. And latency is also an issue. So maybe we need some intermediate scheme, and I think physical layer cryptography would be an option. And we can also show that this physical layer crypto can fill this wide range of intermediate area. And this is actually an opportunistic link when the EVES channel is physically degraded. So, but we can still ensure the information theoretic security at higher rate. So now we know 3 kinds of schemes, algorithmic, crypto, and QKD, and its application is just around the corner. And the physical layer crypto would be an intermediate option. So maybe new generation secure network is to combine physical loads, coding technology, and privacy amplification, and maybe some algorithms. And now we can control the quantum noise in optical domain, and maybe control the thermal noise and RF domain. And maybe in this direction, new industry and business would be opened. Okay, so yeah, that's it. 2 minutes? Okay, maybe left for discussion. Yeah, thank you.
I propose to discuss actually so two aspects. So what I call QKD ecosystem is how QKD is positioned with respect to other technologies, partners, and well, we have discussion about this ecosystem of where we work and with who we could work better, maybe, and of course, and then we could have a discussion about security aspects of QKD and also the environment. So. The first point I propose to tackle is about the relation between QKD and academia. So somehow there are some contradictory statements. If you talk with people now in academia, many would tell that QKD is not really academic anymore. It's like applied physics or it's engineering. And if you talk about people in security business, for them it's very academic, right? And so maybe now we have people that are really running large and ambitious projects on QKD networks and QKD technology. Maybe it's interesting to have statements of what they believe. I mean, what is the role of academia in QKD at the moment, and also how they expect academia to interact with them and them to interact with academia, and also maybe what is the, let's say, the in terms of market, is academia an important market for QKD at the moment, or is it over? So who wants to start?
So my one, okay. So obviously Battelle thinks a relationship between industry and academia is very important. We work with University of Geneva, University of Calgary. ID QuantumCTek also works very closely with universities. I think the relative roles depends in large part on what you're trying to develop and where you are in the product development cycle. So early on product development, it's going to be mostly academia with some input from industry. And as you get more towards where we are with the trusted node, it's much more industry-based with some input from academia, particularly in the area of security and those kind of things. So I don't know if I answered all of your questions.
No, some of them at least. But so it's if anyone has a statement to make at any time, don't hesitate. You raise your hand and we'll give you the microphone. But so, do you have any other or answer?
Mario, I think the academy is very important for our, for our work. So we grown from the university, so the academy. So now we have an interface and connect to the academy research and the industry. So I think the scientists, the people in the academy should be very excited. So we can transfer it, and we are ready all the time to transfer the achievement. And I hope that the academy keep very creative in QKD. So I think there's a lot of stuff we can keep doing. So together.
Okay. Masahide?
Well, in Japan, it's been a long time since the national project had started. So this year it's the 14th year, and the Japanese government expects that the industry should stand alone. So collaboration between industry and academia is really important, but it is time for industry to just stand alone.
Okay, so we move on to a second question or theme about which is very common, and we already heard some statements about this, which is clients and market. So there is a generic question I believe is interesting because also people don't agree, I think, in the community, is whether QKD should target more, I would say, military type of governmental type of applications, which means the highly secure infrastructure and relatively closed market with very big barriers, national barriers and these kind of things. So this is one, I would say, one type of market and one type of future for QKD. Another one is more like this idea of having mobile phone applications, or even what Don was talking. He was talking that we are targeting more the telecom market at the moment, banks and more commercial applications, where you would target larger number of partners. Maybe you would target end users that want to manage their security and that could use QKD. So it's a different philosophy, and there are two different markets, and it's not so clear. At least I think people don't agree about that. What is more mature? What is better? Maybe both are okay. Maybe none is mature. So what do you believe about that?
So first of all, the military markets are maybe in some ways easier to get into, but they're also more constraining. And so we've intentionally targeted commercial applications for this particular project. Now, it's not to say that, for example, if you get FIPS certification, that it can't be used for some government installations, but it can't be used for all. And so I'd say we're very much targeted towards commercial.
Okay.
So from my view, we work on the Chinese market for a couple of years, and we found maybe it's quite different. It's different from the Chinese market and the U.S., the European one. So, and we have a different situation, we think. So the market, the reaction, and quite a bit different. So for example, so in Paris, it's a very nice, beautiful city. So we have very gorgeous, very, very, very great buildings. You will not, I think you might haven't very strong motivated to build new one. But in China, so we are still, actually China is still a developing country, so actually our technique and some base is not such as good as the US and the European. So if we found something new, so we can get this stuff and catch up with someone else and maybe go a little bit beyond. So we are interested actually in the QKD. So we want to try it, use it, and and then I will show, and I already showed the last slide. We have a lot of collaborations. What they are? They are scientists, they are investors, and also they are telecom carriers. The telecom carriers, though, so for example, the China Unicom, the China Telecom, and also the China Cable TV network. So they are interested in that. And also we have a lot of potential customers like the government, the government for the bank. For example, the China Bank Regulatory Commission. They lead the banks. They joined the project. They want to try something new. So they show the passions, and I want to pass the message of its kind of attitude. So, but I think in China it's a little bit different. So the market a little bit maybe easier than other places.
Maybe because you say the country is changing, is developing anyway new infrastructure.
Yes,
so why not
example,
QKD, right?
You build a new infrastructure, and by the way, so we put up our QKD setup maybe. So we have actual fiber source, so we can make the dark one or the light one. So yeah, so the situation is a little bit different. So we are a little bit lucky.
Okay, and so Masahide, what do you think about the situation in Japan?
I direct to find a market in two directions. One is just put QKD functions into the existing product like ComCipher, based on AES. This is a really immediate step. Another one is just work on the new field where there's no infrastructure such as controller area network, and they are just looking at what kind of technologies they should use. So it's a really, a new field and easy to compete with the existing schemes.
Yes, you also mentioned in your talk this physical layer security linked to wireless security, for example. Do you know if those things are really deployed in terms of product, or is there still, what's the stage of development, of industrial development of those techniques? Do you know?
You mean wireless network?
No, wireless security, like you mentioned, opportunistic wireless wiretap.
Well, on our RF domain, there are several venture companies spin out from the Georgia Tech, and I think a Chinese company, wireless smartphone companies.
Okay.
I forgot but there are many patents, and there are several businesses.
Okay. Yeah. So so if we stay in this question of clients and market, so of course you're not forced to tell us all your secrets when you want to sell QKD, but in general, why do you think clients could or should or are interested in when you address them? Or because you are trying to actively develop these networks, so you have to convince people to try it at least, right? So what do you think is at the moment the key way to motivate them?
So what convinced Battelle to actually start encrypting their networks was, while you never know whether RSA or Diffie-Hellman is safe, you do know that QKD is safe. And so it was that knowledge that we're secure rather than the hope that we're secure that motivates us as much as anything. I think many of our clients would pay some extra for the feeling of security rather than just the hope of security. So that's what we're looking for.
Okay.
So for us, I think we have the right to control the information we have. So something like we have QKD, so we know how to use it, and then we have to make it. So I think if we integrate this kind of technique, we can control. So something like this.
So I think that's part of it.
So that opens the market for more products, right? Masahide, or what would you?
Well, maybe new values like ability to detect hacking would be maybe appreciated by customers, and some key exchange infrastructures at the physical layer would be something new, and some high-end users understand the such values.
Okay. So now it's a question about that. Actually, that was asked by Philippe Granger already, but we can maybe ask it again, or maybe get more details, because so we see all these large projects, very impressive actually in terms of investment and numbers of nodes of QKD networks being deployed. And so a natural question is what is the business model, right, with this network? So because it's an infrastructure, it will be Don, you mentioned that actually already you have some plans for your network in Ohio, right, to be open to some maybe researchers, or but so in the long run, when you deploy a network, usually you have to make a business plan. What kind of service you want to sell, how many customers you will have, and based on that you should decide on a price. So all this comes together. So so what's the status of what you can communicate about that at the moment, or what's your opinion? Or
yeah, so we probably won't share too much with it, but there's sort of two models that one can look at. One is that I just want to build equipment and we'll hope somebody else buys it. That one is an okay model, but it's pretty limited. The second model is where you actually provide a service, you provide keys to end users. And that's a good model, but it's got to, you got to go big or go home. It's not something you're going to do on a small scale. So, those are the kinds of things that we're looking at as we move forward.
I think the telecom carrier or the operators, they will play an important role in the business model in the future. I mean, maybe they are doing now. So I know they are doing some research on how to charge it, something like that.
So you think that the telecom operators somehow would define the business model, right? Or
they want to use it, they want to provide a service to their customers, and using this setup. So we make the products, make the solutions, provide all this to the carriers. They provide it to the customers. They be rent, something like that. So like you get phone free, but you pay something like that. So I think it's make bigger, and the bigger the better. So the customers grown, and we can get feedback, something.
Okay, so it probably means that those calculations have to be made by somebody, but it would be more, you believe, the network provider, that they would look at your technology, your price, and they would see whether they can provide a service with that, right? That's maybe the situation. Yeah. Okay.
I'm not quite sure about the business model. We are just looking for appropriate ones, but maybe we will start with a kind of a practical service connecting our institute and some collaborating companies like space divisions or national security solution divisions. So it's sort of a kind of a service provided by the government, or maybe so maybe I'm not quite sure. We are just looking for a business model.
Okay. So let's move on to another question, which actually I hope maybe people in the audience also have something to say. It's about collaboration, right? So we could see that the three QKD network large consortiums, they work in parallel, but we know that there are probably topics where collaboration between on industrial matters and commercial development do matter. So standards are clear examples of that, but maybe there are other ways of thinking about collaboration given at the stage where we are. So in terms of, if we think about the community, we have the QCrypt community here. I mean, do you have some collaboration themes to promote? It could be also collaboration with other communities, not QCrypt, but actually maybe telecom people, classical crypto community. Yeah, what can you say about that, or what do you have to suggest? Do you believe there are some things we could do together better than we do like in separate groups?
So obviously we're a big believer in global interaction. We're working with a Swiss company. U.S. companies have some issues working with foreign companies because of export control problems. So it does limit us a little bit. I think how systems cross country boundaries and that kind of thing is something that should be dealt with on a global level, just like IT is, for example.
Yes.
And I think as we start to move away from academia into commercial applications, I think you'll see more and more of this internationalization of the IT facilities. So I think that's a good thing.
Because the export problems that several probably already have about QKD could be solved maybe more globally, you think?
It could be.
Yeah.
Right.
Mm-hmm.
So we are very happy if we can have a collaboration. So that is why we are here this time. So after 5 years of focusing on operating as a company and doing the market, so now we get some message, and I want to pass a message. So the market in China looks like fine, it's promising. So we want to make ourselves a company more competitive. So we welcome to have a collaboration with others in different levels.
For example, do you foresee working? There is this group working on standards. Is it something you?
Sorry. Yeah.
There is this initiative to work on QKD and standards. Actually, under EDC, is this something?
So we are thinking about this. So for standards, for certificates, how to regulate the markets. I think at first you have the market, the people you're using it, and then you think about how to make it can connect to each other and link it together. So we are thinking about this, and we do try a little bit from our own view. So we try to be much more ready, and then we communicate to another. Okay.
Well, I think the most important global collaboration is to establish the security certification standard. For example, MOD, Ministry of Defense in Japan, really want to know how to certify the security of any crypto system, and QKD is not an exception. And so maybe there must be a certain established way. Currently, each team in each country just sell. We did this key rate and distance, but no one knows what kind of security are just realized in such systems. And maybe third party should be able to just measure a certain checklist, and they give a certification for that. And otherwise, mission critical institute or organizations cannot introduce QKD.
Sure, I think the international standard will help us to convince people to use it somehow.
Yes. Yeah. So certification. Yeah. There is actually a question later about that, but it is very important for sure. So let's move to the kind of genius question. So well, it doesn't have to be realistic, but if you had a genius that could fulfill 3 of your wishes, and it doesn't have to be rational or realistic or easy, and your goal is to sell QKD more, what would you wish?
So is putting Vadim in that little thing, is that one of our options there? Or?
So is your first wish? Or?
So
you have 2 left.
I have 2 left? Okay, so the first thing I'd like is a working quantum computer that can factor numbers bigger than 21. Because I think that would probably be to make it the easiest to sell QKD systems in the future. The second thing I'd like are things which allow us to mix more stuff on one fiber, because you talk about business models, what really hurts us is the cost of fiber, far more than the cost of equipment.
Yes.
And so that's a big one for us.
Okay.
So I have 3 wishes. The first one may be a crazy one. So I hope everyone is crazy about QKD, and no matter what is, they just want to buy it. It's the first one. They're crazy about QKD. They are crazy about QKD. The people all crazy about QKD. They want to buy it. I mean, in spite of what is that.
Your first wish.
It's okay. The second one, I hope we can realize the mobile and the various mobile ones. That you use your mobile phone or something like that, a portable device, directly generate quantum key.
Okay.
Something like that.
Like miniaturize and make it mobile.
Yes. No, but the single photon in that way, it's not easy to detect something like that. So want to reach maybe somehow. So in that way, we will have bigger, market. So everyone has quantum key in your pocket. So it looks nice. It looks very nice. And the third one maybe, and now there's a trade-off between you have the distance and the high rate. So if they can both go to one direction. So the longer the high rate, yeah, maybe something like that. But just wish.
Okay, thank you. Professor.
Yeah, maybe the same. Just miniaturize the QKD system in the laptop size and really cheap, like $1,000 or something like that. Then QKD would be accepted.
Yes.
Someone do this.
Okay. So we'll tell the genius. Yeah. So now we move more to the kind of security questions and come back to this notion actually that is common to all your work, is that you need trusted nodes, right? So this, so again, there has been a few questions about this, but so first, I mean, when you come up with these trusted node ideas and you see your government or customer, or how do they accept it? I mean, do they accept it, or do they challenge it, or do some people challenge it, right?
Well, so physicists challenge it more than everybody else, but I'll give you an analogy. I'm an engineer, and when we design bridges, we don't look for unbreakable materials. We design bridges given the materials that we have available to us. And the same here. There's obviously parts of trusted nodes that are more breakable than the QKD part, but all it has to be is secure enough, and that's what we're after.
Agree with that. Something else? Sure, we have lots of reasons. So we always pass it through to the customer, it's practical, it's economical, something like this. But I want to try to use from another view. So maybe the case, maybe not. So if we have the assumption, when we have the quantum computer, so we have to use QKD, but maybe not. So if we have the assumption we have to use the QKD, in that moment, can we have a practical quantum repeater? I'm not sure. So though, as I know, the technology levels now developed for the quantum computer and the quantum repeater, they are comparable, more or less in the same level. So when you reach the quantum computer, just like, for example, D-Wave, although they don't the general one, but like this big, huge one, so it is already suitable for crack the cryptography. But meanwhile, if you have something like that big quantum repeater, you cannot fit it in the telecom carrier's room. So you have a bigger network. Maybe every 200 kilometer, 100 kilometer, you set one. That's so big, it's very costly. So even that in that moment, the trusted relay is still suitable for using. So as long as you can you can make it safe. So from our side, from China, the telecom carriers they want to be in charge with this. So we can guarantee the security or the safety of our room, something like that. So also we can do some engineering stuff so to make it
okay,
portable, something like that. So I think the possibility you use the trusted node now and in the near future, the possibility for using that is bigger. So why not we use it now? So we can start using now, something like this.
Okay. Masahide, are they accepted?
Well, Roman, why don't we have a comment from the audience, and maybe this is a Gregoire, right? Oh yeah, Gregoire. Maybe
Gregoire wants to
you should say something.
He's forced to say something now, right?
So you tried to get out of it, but it didn't
What do you think about the trusted node paradigm?
Well, I think Don told us already, because when he first told me about trusted node, I said, no, it's not a good idea. He said that during his presentation. And I think it's a reaction that physicists tend to have, but in practical security application, there's less resistance. And so I've been personally quite surprised, I must say.
Okay. So no one objects to trusted nodes in the room?
So the scientists, the physicists keep working
Maybe
on how
not
to
now.
solve this problem. So.
Well, I've heard people objecting, to be honest, right? I've seen many classical cryptographers because they work in the paradigm of end-to-end security that you can get with asymmetric crypto. So they don't want to give this up, right? And so so there are some people objecting, maybe not us, right? But maybe not even physicists, but maybe cryptographers. Okay, so it's another a bit spoiling question. It's an objection from cryptographers that I've heard a few times. So the situation is that that people in the security business they are a lot more concerned at the moment about securing storage with the cloud, for example, than like you know this recent stories about iCloud, and so they are more concerned about storage security than actually transmission security. So so the objection about people when classical cryptographers meet QKD people, they say, but well, you are developing, putting a lot of effort in developing what you claim is ultimate security, but it's only for data in transit, and you provide nothing to secure storage. And so is it true? I mean, are we really missing the big applications of what is needed in crypto, or is it not true? Is it unfair to say that? What would you respond to this objection?
So I actually agree with this a lot. You know, if you look at network security, the biggest number one, or the biggest problem is the people who run the network. And the second biggest problem is the keys that you use to secure the data that's stored on your servers, for example. And when hackers go after something, they always go after the keys. QKD is, I mean, it's called quantum key distribution, but what it really is if you look at one-time pad and QKD as it's currently practiced with an integral encryptor, all it really does is protect the data in motion, not the data that's stored. But our implementation of the trusted node, and I'm sure others as well, is all about moving the key back and forth. And so by being able to securely transmit the keys, we can store the data in an encrypted fashion on servers, and then distribute the keys to the people who need them so that they can decrypt the parts of it that they need to do. So I agree.
Okay, you would agree, yeah. Yong or?
The data storage is very important, and I agree with that. Mm-hmm. So as I know, there's several people, several groups that they're thinking about using quantum key distribution to help to store the data. So I hope they can have progress. And nevertheless,
can you be more specific, maybe, or about what they do to use QKD to?
I'm not quite understand actually.
Okay.
So, but as I know, so you have the data storage, and one day you need it. You need this. I mean, the secret data. You want to get it. You have to transmit it. So, the channel we can protect. At this we just use the QKD. So I think maybe we missed a big part. So, but they link together. So they are the total solution. So.
Okay.
So they should combine together.
Mm-hmm. Anyone wants to react? Or Masahide?
Well, I think QKD would find a kind of a new route for the distributed data storage. So maybe, data is distributed in the different servers, and the password should be encrypted via QKD. And also data backup is really important, and such sort of a data transfer can be encrypted via QKD. It's not a frequent communication, but once a day or something. So.
Mm. Yeah.
By the way, one more question to Gregoire. Maybe you are in the front to exploring the market, and maybe you are contacting a Google or a Microsoft or the giant in the web. And if possible, I'd like to know what they see or how they look at the QKD. Have you ever contacted Google or Microsoft?
Or do you want to come down, Gregoire? We have a seat actually hidden here.
So yeah. So first thing, if I would like to comment on what you have on the slide about the security of data storage. The security of data storage is really a question of key management. And it's particularly important for long-term security. And I think that QKD really has a role to play in this. in backing up keys securely. And so I think there's really a big opportunity in this, which is a bit more difficult to address because it requires more interactions with different applications, so it's a bit more difficult. But I really believe that there's a big opportunity there. Now, in terms of the big actors, I think there's some interest in QKD, but they're still really, trying to understand where it fits, and the distance limitation is a big concern for them. Because if you talk to IBM or Google or Microsoft, data center communication is a big problem for them, but their data centers are not on both sides of a city; they're across all the U.S. And so, as long as we don't have something to offer them in terms of long distance communication, it will be very limited for them in terms of applications.
Yeah, I can add also that in the I think it was the last slide of Bart Prenell's talk, he somehow mentioned this situation where for cryptography in one place was not very safe, and then the incentive to have distributed secret management somehow, something like this. And so in this sense, you have distance coming into the game with secret, and then maybe QKD could be, it's a way to distribute secrets over distance. So, but it's intuitive. Then you have to make it real. Okay, so that was for the storage question. Okay, so it's something also we already tackled before. It's certification. I think with the statements we've had so far, we pretty much agree that it's very important. Maybe a statement that would be interesting to have, because it's recorded, right? It's when do you believe it will happen? I mean, when do you think the first QKD system will be certified, based on what you know today, and what has to be done for it to speed up, maybe, right?
So there's actually two aspects to that question. The first is, if you look at U.S. certification methods, there is no way to certify QKD standalone now, just because it's not part of their nomenclature, not part of their language. When will that happen? I don't know. That's probably going to be a while. Not until, certainly after the new FIPS 140 is released, which is going to be a couple of years, I think. But you can certify QKD instruments, which we intend to do, even though there is no way to directly certify the quantum part of it. And so to do that, you have to mix the quantum side with the classical side in a way that both sides are happy, and that's the approach that we're taking. So we will be certified. We expect that to happen next year.
For example, encryption certification with quantum key QKD inside, without QKD being certified by itself. That's what you mean, right? Yeah.
That's correct.
So the QKD should, you should use the QKD with the application together. So I think from our view, so the certificate, something standard should be into two parts. One is if you use a QKD, this setup is satisfied the user or not. So we can, that is very classical and so conventional certificate, something like that. But for the QKD stuff, we're still under studying, and I think for the very huge the backbone network, so it can be the test band for reaching that point. So a couple of years maybe.
Or maybe Vadim can have a statement about this, or when do you think QKD can be certified?
I have no idea.
Well, you're in a good position to have an idea, right? Or okay, that's a statement anyway.
Actually, it's a never-ending task, and the problem is when we can set certain, the version 1 certification standards. Like maybe I think we have to prepare several QKD systems at the same place, and then just compare it to each other. This is only the realistic way. And well, maybe the camera is shooting me, so it's really hard to say. But real QKD systems is really unstable. there is a hysteresis effect of the modulators, bias are drifting. Recoherent source is not a Poissonian, anymore in realistic conditions. And we have a finite length analysis, but there is no satisfiable theory to deal with such sort of a statistical deviation. So maybe we have to be honest and present such sort of things and then find a countermeasures or solutions.
Sorry, you asked suddenly, so I had to think what to answer. At present, it takes a long time to find new vulnerabilities in QKD. So my lab spends maybe 2 years from the idea of what kind of new vulnerability to look at until we get some research results. And that's original research, of course, but we are busy. We have new projects in development. We still have ideas what else to look in the QKD systems, especially in the practical QKD systems that the companies deploy. So I don't know. You can make a standard which tests the systems for existing vulnerabilities, the ones which are known and maybe countermeasures for them. So that kind of standard can be made, and I will certainly be happy to participate in forming it. But the work on security testing is not complete. There is still more to do in this. We will still see more original research in this direction. That might not stop us from making a security standard, but expect it to be updated over the next few years.
Yes. Any?
Standardization is somehow expensive, and I think there's not money or global money for standardization now, right? I mean, there's a small group of 20 people meeting twice a year, and this is not comparable how usually standards are done in the telecom world, where a group of 600 people meets nearly monthly or something like that. And therefore, the standards are not here for QKD. So my suggestion would be that everyone who applies for a grant somehow reserves money to participate somehow in a standardization activity. Then you would have some standards within 2 years, and I fully agree with Vadim. They are not static standards, but need to be continuously updated then.
Any statement? Any question also you want to ask? We're coming to the end of the session, so if there are points you want to raise, or I have a few other questions, but you're probably hungry, or maybe not yet, but you can think about it. Yes.
I don't know if you're aware that in the sanctions EU imposed on Russia, QKD system is on the list of sanctioned items. I don't know what you think about this. It specifically mentioned QKD systems and high performance computers. Yeah, for export to Russia for the Ukraine's the sanctions.
Sounds very interesting.
Excellent news. Now we will have QKD research in Russia, with national regional systems.
So it's probably a success for QKD, right? It's starting to be well known. All right. Yeah.
So there's actually 6 countries that are sanctioned from QKD. There's 5 that are supposedly terrorist harbors, and then Russia. It'll change.
Okay, you can think about questions. I'll ask another one then, or. Okay, so it's also a point that has been tackled, well, actually several times. But is it, Professor Sasaki actually showed also, I think, idea in this direction, is how useful or and what can we do by combining somehow ITS security, so information theoretic security, like we have with QKD, with computational security. I mean, can we? So so we have to realize first that that's what people are doing at the moment when they try to sell QKD. They mostly try to sell QKD plus AES. So first question is that, is it acceptable? I mean, probably you will say yes, but what can you claim? I mean, or do people care when you say, I have this key, it's perfectly secure, and then I use it with something that's, we don't know whether it's perfectly secure? What security do I have in the end?
Well, so we could go back to the bridge analogy, right? We do things that are as strong as we need them to be. We actually think AES is very strong. And we think AES has a life right now that is approaching 30 to 40 years before we really need to start worrying about whether we have to replace it. From a practical standpoint, we don't have an issue with AES.
Yeah. Then nasty people could even say, okay, but then you could amplify key with AES. You don't need QKD then, if you believe AES is really great.
So there are still reasons for using QKD. So we trust AES as a symmetric key, and it is true that you can, for a while, keep amplifying the key to have a new key. But at some point you have to do something else because you're going to run out of key material. There's attacks against that kind of thing as well. So we don't see that it's an either or. We see that they work together in a good fashion.
Okay.
So as long as it's helpful, I mean, using QKD with AES together is helpful, I think the customer can accept it. And for us at the AES, I think it's not such, I mean, it's trustable in China maybe. So we want to improve it. So I think for us it's very promising.
Okay. And you don't receive objections or?
Yeah, maybe I think this combination is also with our interface. I mean, we can communicate with the conventional cryptographer experts. So there's our past. So
okay.
So
and Masahide, do you have a statement about this?
Well, maybe yeah, QKD. If QKD can operate much faster, then that's ideal. But the speed speed of the QKD is really limited. But the users really require 10 Gbps secure link, so it's only the option at the moment.
Mm-hmm. Yeah. So it's a realistic one, yes. Yeah, I guess that's. Yeah. Everyone agrees with this. Anyone thought about a question? Do you want to address to everybody? It can be on anything, right? Yes?
If you look back like 10 years or 50 years ago, modern crypto was is not popular. But after that, there has been many security accidents reported on news. And now everyone thinks that modern crypto is important. And do you think that type of change is needed for QKD to be popular in the future rather than improving QKD itself? I mean, am I?
So you're saying that, do you think that it's the best way to go is to improve QKD or to actually do something else based on technology?
For modern crypto, there has been two reasons for becoming popular. Not only the property of the crypto itself, but there has been many security incidents. And once there's incidents, people realize that crypto is important. So,
question to me? Or?
Like RSA might be broken suddenly, then QKD becomes popular, but otherwise it never becomes important.
You mean QKD can only become important if something, if an incident happens?
In some sense, yes. So.
So you mean, so like conventional crypto, if there is no big accident on conventional crypto, QKD cannot really develop. Is that what you want to say, or?
In my opinion, that's how classical crypto became important in history. So
that's why we need that quantum computer that I was asking for.
Yeah, I agree with him. And also, for example, the PRISM issue. So we know a lot of, a big amount of data theft maybe happen during the transmission. So it helps, I think, to increase the.
I've seen Grégoire several times talking about the market of security, how it's complicated because people, they hide what happens, and only bad things that happens motivate them to do something. So it's a specific type of market. But then the question is, do we really need to hope that classical crypto will have problems, or is there room without that? Maybe it's another question.
I think that fiber tapping is already enough threat, and MOD is really worried about this. And the issue is just the cost. If the QKD can be cheaper, they start to use.
Yes.
Thanks. So yesterday we had an interesting talk from Bart about some like classical infosec type perspectives on all this QKD stuff, and I think we picked up from him some comment about how national governments don't seem to like the thought of decent cryptography to be sort of widely available. I think he said they feel like they have a right, I think the word he used was, to access our data. So in that context, should we be worried more about things like trusted nodes? Like, can you have trusted nodes if that's the case? I mean, you have to put them in a city somewhere, right? Governments run cities. You no longer have any kind of real assurance about these keys if that's the world we live in, right? I mean, it possibly has implications for these authentication of QKD systems. I mean, who's responsible for setting up these standards? Should we be worried about those as well? Is that kind of thing important? Are you guys worried about that, or are we just sort of pretending that's not a problem, or are we just selling it to governments, or what's the?
It depends on the user. Like a military or defense agency have already had a really trusted node, and they are really proud of it. And fiber is really long, and they cannot manage by themselves. That's why QKD could be useful. Trusted node is a kind of a realistic in some sense.
So I understand what you're saying, and that's one of the reasons that we combine classical and quantum methods on the trusted node, is because some people trust one, some people trust the other, and neither one trusts both. But when you combine them, they do seem to be much stronger.
I mean, I think maybe the question was in the direction of legal interception, because the government actually access to the data which their citizens are transferring. So they, ultimately they will get access to it. They will demand of you as the telecom operator that you deliver them the keys that you store at the trusted nodes. Probably. Yeah.
I have the impression here, it depends, it was this question, whether you believe QKD will be for end-user telecom type of networks, where actually you would have to trust your network operator that typically could be I mean, would have to obey governments, right? And as they do today. Or if it's already anywhere an institution, it can be a small one or military, that is already managing a closed network, where I mean the trusted nodes are already in place, or they have this culture of doing that. Then maybe it makes more sense, right? But that's true that probably if you try to deploy trusted nodes in an institution that has no culture of managing trust, and cannot guarantee anything, or at least not the level you want, then it's a problem, right? So.
Yeah, I mean, for the private end user, you will always have the kind of problem that the government will know the key. That's, I mean, yeah. If this is a problem for you, if.
Do you have any other question? Or if not, I think we can close the session and prepare for the dinner. So we can thank the speaker